As I think we've been saying for a while, Tehillah has been given a grant called Scientists in the Synagogue. And we are very blessed to indeed have scientists in the synagogue. Daniel, being the astrophysicist that he is.
That just means I'm spaced out. And yeah, I'm very, very happy to lead this discussion about Genesis, about Breshit. And I'm going to share with you how I'm inspired as an astrophysicist by the story of Genesis. Breshit bara Elohim et haaretz, when God began to create heaven and earth. So this is chapter 1, verse 1. And the earth being unformed and void, with darkness over the surface of the deep and a wind from God sweeping over the waters. V'yomer Elohim yehi or v'yehi or. God said, let there be light, and there was light. God saw that the light was good, and God separated the light from the darkness. So you may ask, how is it as an astrophysicist I'm inspired by Genesis? And really what we see here are humans asking questions about where do we come from, where does everything come from? And I like to pull up this image from a 19th century lithograph, though it looks older. Humanity has been asking these questions for millennia, but we haven't had the knowledge or the understanding. Pre-scientific humanity had one way of looking at it. And now that we've developed the scientific knowledge and method, we have a different way of asking and answering these questions. And it's really humbling to think of myself as one in a long line of thinkers that truly goes back to prehistoric humans. Has to be. So where I'm going to focus is when God began to create heaven, which I interpret poetically. I stopped writing poetry when I was a teenager, though, and you should be thankful for that. But I interpret that as the Big Bang. So what happened? The universe was created in an intense burst of energy, and the universe was extremely dense. It was so dense that if you were standing inside the cloud of the early universe, you wouldn't be able to see anything. Light couldn't travel. And then as the universe expanded, you're like in a fog, and the mist slowly dissolves, and suddenly you're able to see what the universe looks like when it's only 377,000 years. So to put that into a human perspective, with the average lifespan in the 80s here in the United States, that corresponds to 1 day in the lifespan of a human. So this epoch is known as the Puniverse. What we're seeing here in this picture, in the orange are slightly denser regions of space. And because they're denser, they have more mass, they have more gravitational attraction towards them. They suck matter towards them. And the blue are less dense regions of space, so they don't have as much strength to hold the matter close to them. And what we're really seeing here, these fluctuations in density are the seeds for the formation of galaxies and stars. So eventually this grew up to be us, as we see it now, 13 point some odd billion years later. And I want to move on. So this is what you see at 377,000 years. There are no stars yet. So there are no sources of light. So where I'm going to go next is V'yomer Elohim Yehior V'yehior, which I interpret as the first stars. So how did the first stars come to be? This is an active area of research that astrophysics has been basically dealing with for half a century at this point. And the stars formed out of the clouds from the Big Bang. So as the universe expanded, you saw these clouds, these little fluctuations, they turn into clouds. And the clouds are made up of hydrogen and helium, 90% hydrogen, 10% helium, trace amounts of lithium. These are the elements that were formed in the Big Bang. None of the other elements existed. Yes?
Could you just say why those three?
It has to do with nucleosynthesis in the early universe. It's really dense and hot, but it's also expanding and cooling down. So the universe didn't have enough time to synthesize through nuclear fusion to elements beyond lithium in the periodic table. So where the other elements come from that make up our body, that make up this table, the chairs you're sitting on, came from stars, from the interior of stars, nuclear fusion happening in the inside of stars. Stars are factories to forge the elements. So when Carl Sagan said we are star stuff, we are, except for the hydrogen. That goes back to the Big Bang. So these clouds are held, and yes, if you want to ask a question, please raise your hand. There is no, well, did you bring the number 2 pencils?
No, I did not.
All right, so there is no quiz.
There's no quiz
this
at the
time.
end of this, no.
Yes, please.
Why were there different densities in different parts after the Big Bang?
That's a question that we're still trying to understand. It's believed to be due to quantum fluctuations in the early universe. And someone right now is doing a PhD project to try to answer that question. Yes, please.
So if we're all from stars,
Yeah.
and stars is all from that,
Yeah.
then we're all connected.
Connected in what sense?
Shema Yisrael Adonai Eloheinu Adonai Echad. We all come from the source.
We come from the Big Bang. If you want to call the source the Big Bang, yes.
So that, and this is, and what you've already, what Counselor Lois has sort of put out there is there's science, and then there's the spiritual journey. And I want to say that it comes from our human need, desire to know why. You just asked that question. Well, right, and the truth is, for so many things, we don't have the answer. And when we put this next to the biblical text, for its time, pretty revolutionary. But now we're taking it to the next step.
Except for one thing.
Yeah.
Which came first?
The chicken or the egg?
The science or the source?
I have a biology friend I'm always arguing with about that. Yes.
Before the creation, where did the energy come from?
This is
One of
an
the questions.
open question, and this is the cutting edge of scientific research is what caused the Big Bang. And we as scientists have a belief that we will be able to answer that question someday. Maybe not in my generation, but we have to leave something for the next generation to do. Was there another hand over here?
Your theory of mapping Genesis to the Big Bang, is
Yeah.
that a widely accepted, I say theologians, or is it particular?
Well, I'm not a theologian, so I don't think I can answer that question.
But it is a common way of looking at it, and for those of us in the liberal Jewish community, I'm going to frame it that way, it's certainly often the way we teach the 6 days of creation, and part of it is the fact that, wait a second, there was light before there was the star and the moon and the sun, so there's something else going on, and what Dan's going to be talking about is the formation of stars. So yeah, before there could even be stars, there was that mass with those other things going on. Now, did we know that? That's what I said. Are those who wrote this down, did they fully, I don't know, it was intuitive. Who knows what their inspiration was? But the fact that there can be any alignment at all is sort of, I think, more than sort of, is quite phenomenal.
Yes.
Yeah, I mean, I always, I know that this is science, but it's hard, when we're talking about this to, not putting like a theological aspect to it, and in line with what you were saying. It's like I always interpreted the first being the awareness of God.
So that's the point. So that's a different, right? So we're going to stay a little bit more on the scientific track and just sort of weave in some of the more spiritual. I'll leave you, yeah?
Well, the whole thing about faith, I mean, I love what you just said. When you said that scientists have a fundamental belief that they will eventually figure it out, they'll eventually find out.
Yep.
And that's real faith.
Yeah, that is.
Yeah, I just want to say one thing too, just in my sense, you have some other echoes of this throughout, not only biblical, but related to this, like the whole philosophical, theological concept of creation ex nihilo, people meditating on precisely what I would say in scientific terms might be what was there before the Big Bang, right? It's like, in some ways, they're struggling, like, okay, well, if there's this act of creation that created everything, what was behind there, and, you see as many answers to that as you see.
Turtles all the way down. But there's also the response, what was before God? So it doesn't matter whether you're talking about the Big Bang or God, there's always a what was before question. So these clouds in the early universe are held together by gravity. That's pulling everything inward. And what happens is the cloud gets smaller. Now, many of us have bicycles, and when you pump up the air in your bicycle pump, as you squeeze down the air in the pump, the tube gets hot. And that's exactly what happens here. So as the cloud gets smaller, it gets hotter, and that heat pushes out against the gravity. So if the clouds could not cool, they would not be able to form stars, and we wouldn't be here. We're all stars, by the way. The way that the clouds cool is that there's a little bit of molecular hydrogen, that's two hydrogen atoms stuck together. We symbolize that as H with the number 2 subscript. And imagine on the summer day, you're looking at the pavement and you see the shimmering of heat coming off the pavement. The H2 does that to the cloud. It radiates the heat of the cloud away. And it enables the cloud to cool so that gravity can collapse the cloud and form a star. So, how does the H2 cool the cloud? What we have here is a little cartoon. In the upper left corner is a hydrogen molecule. You know it's cold because it's not rotating or vibrating. And in the lower left, we have a hot hydrogen atom. And it's hot, it's moving fast. When things are hot, they move fast. So the hydrogen atom, which is hot, is eventually going to hit the molecule, which is cold. And when the hydrogen atom hits the molecule, oh, it missed. When it does hit it, the atom slows down. It gives up that energy to the molecule, and the molecule is going to radiate that energy out of the cloud. Okay. So that's the process by which these primordial clouds cooled. Okay, we have the question, how did the first stars form? Well, they formed out of clouds with H2 because the H2 cooled the cloud. So if you want to understand how the H2 got there, you need to understand the chemistry, which is where my research comes into play. So we start with a hydrogen atom, which has a proton in the nucleus that's positively charged. And there's an electron orbiting around it, which has a charge of -1. The total charge of the hydrogen atom is 0. So we symbolize that with a capital H. That associates with another hydrogen atom, but this one has an extra electron. It's special. So it has a total charge of -1. So we have the H and the H- associating to make molecular hydrogen. You have the 2 nuclei sharing 2 electrons, and the extra electron detaches. We call this process associative detachment. Now, I know a number of you are therapists, okay? You are not going to find this in your DSM, and no, we do not prescribe the primordial lithium for this. Okay, this is a fundamental chemical reaction that led to the formation of the first stars. I want to emphasize this is chemistry because you have the 2 nuclei not fusing into one nucleus. They're staying separate. So it's chemistry, please. Okay, this shows how poorly we understood the chemical reaction of H minus on H making H2. On the left column, on the left side of the plot, we're showing how fast the reaction went forward. And on the bottom, we're showing the temperature scale. And the black circles show the experimental measurements that were done before my group started this work. And the error bars on it show how accurately we knew the results. Everything else on this plot is a theoretical calculation. So naively, you'd think that the theories which match the experimental results must be the right ones. Next, Bavakasha. We have the newest theories in the blue squares and the magenta dashed curve. What we find when we started this project, that theory and experiment had not converged. So this is the idea behind the experiment for how we measure this reaction. We start with a gas discharge, and this is a gas discharge. It's a glass tube where you put some gas in and then put an electrical current through it, and it breaks the electrons apart from the atoms. And you create a discharge that glows. You might see it if you go to a bar or something like that. And we pull out a beam of H minus ions. So here's our beam. Then we take a really, really powerful laser. We didn't buy it from these guys, though. And we shine that laser across the beam, and we rip off the extra electron with an efficiency of about 10%. So now we have a beam of hydrogen atoms that are embedded within a beam of H minus, undergoing chemical reactions, and we detect the H2 that's formed. So that's the idea. What does it look like in real life? Here's a picture of the experiment the day after we got first signal. It took about 2 years to build this. The smiley balloons were from my friend Barbara, who brought them to celebrate. In the behind the battleship, whatever color that is, we have an ion source to make H minus. We extract it out. We bend it 90 degrees. We have our laser in a black light tight box because it's 2 kilowatts. You could cook a steak with it. We shine the laser across the beam. We make our hydrogen atoms by ripping off the extra electron. The hydrogen continues on ballistically. It has no electrical charge, so it can't be affected by electric or magnetic fields. We form the H2 in the interaction region. At the end of the interaction region, we get rid of the H minus. You can see that little yellow arc going up. Now we have H2, which is neutral, and hydrogen, which is neutral, neither of which can be affected by electric or magnetic fields. So how do we detect our signal? Is we use a trick. We send both beams into a gas cell of helium. Collisions of the H2 on the helium ionizes the H2. It's now a charged particle, and we can use electric fields to direct it into our detector. And so what we do in this experiment is we measure the H2 plus as we vary the relative energy between the beams. These are the data I showed you before. And when we put our results on, the solid black line shows our results. The dashed black line shows the uncertainty, how accurate our measurements are. And what we see is that we're in good agreement with the blue squares and the magenta curve, theoretical calculations, but we are in disagreement with the previous other work. So theory and experiment have finally converged. What we find is that H2 forms faster than previously thought, which means that the first stars formed faster than we thought. Toda rabba. We're all done. Shira, you can go back to your seat. Thanks very much for your help.
So we thought this was another way of looking at when we see let there be light.
I'm kind of in the creation is renewed every day mode, and I'm wondering is that like, we still have stars, are they the old ones, or do we have new ones all the time? Like, is creation still happening?
Star formation is continually happening, but the universe has peaked in its star formation process, and the rate at which stars are forming is decreasing as the universe gets older and expands.
It happens that I'm giving a paper at Mount Sinai Medical School with the title, Psychoanalysis is Scientific. Now, from today, I already have one sentence to change in my draft paper. Because amongst the things I say is, well, astronomy is an observational science, and you've just shown me how your work is experimental. So thank you for that.
That's great.
So I hope this gives us another way of looking at this text that we're all very, very familiar with. And it's we read it every year. For those for whom it's not a regular reading assignment, I don't know if it's ethical you ever look at the beginning of Genesis, but I'm sure it's there. It's in the zeitgeist, right? To take it and to say, oh, this is how we can understand it scientifically. This is how we can make sense of this. It's really quite extraordinary. And from my perspective as a rabbi, it pleases me to know that those ancients had their pulse on things, right? They did not know that it was chemical. They did not know so much. But in the sort of larger picture, they had some sense of it all. And we are not going to that place of, people were asking what was the initial charge. In our tradition, we're not talking about the clockmaker out there. Now, and there are other traditions where that is definitely a belief that there is a great clockmaker who, started rolling the ball down the mountain. Not where we are. We're in some ways on the same place as Daniel is in his research. We are still grappling. We are still wrestling. What? Experimental Judaism. We're still we're wrestling. We're wrestling with these questions. We don't have answers, and isn't that a lot more fun? I think than being told, well, this is it, right? So I want to thank you all for. Yes, Howie, come on up.
No, I just wanted to say that even though we don't know that, it doesn't invalidate the power of the stories that we're telling all the time. And this tradition has pulled out so much wisdom from that. So that's what
Howie is saying that science doesn't minimize the strength of the stories that are in our tradition. Thanks.
My father would ask you, how do we know? How do we know that it was 377,000 years? So there's my question.
So we know the 4 laws of physics, and well,
Some of us know.
Some of us do.
And some of us not so much.
Scientists. Yeah. And when we look out in the sky at night, the further you look away from us, 1 light year you see 1 year ago, 10,000 light years you see 10,000 years ago. So the further you look back, or the further you look away from us, you're looking further back in time. And we know how time scales with distance. So we're able to play the movie backwards. Yeah, it's pretty awesome. Because when I was a kid, we didn't know that the universe was 13.8 billion years. It could have been 10, could have been 20. We didn't know.
The thing I'm struck by is that as cutting edge as this is being, it's all catching up to what's already happened. Like, we're proving what's already in the universe. There's nothing like what's beyond that. And it just leaves me with a whole world of wonder and mystery, which is completely, as Howie was saying, just completely tied into spirituality. So, thanks.
I have one more question, just one more question.
Last one.
On your video, the two blue dots, did they ever get to touch that one blue one? Because you left us hanging.
So when the collisions happen, they are coming within nanometers of one another. 10 to the minus 9 meters, 0.0000000001. I think. I always have trouble with them. I run out of fingers. Thank you for the discussion.
And we want to say thank you to the Ethical Culture Society of Riverdale for joining us today and for making this possible. We loved having you here. And you're free to stay as we continue our service.